Can you hear me now? Yes, you can. Okay. Okay, let's start again. Welcome to BayChi. This is the, hang on, I'm going to get my slide in front of me. Where is it? Is it up? Do I have it? No. Okay, everybody can hear me, right? Okay, so welcome to BayChi. We are, Zoom quit unexpectedly. Is it still going?
I'm not seeing your slides, but I'm seeing the meeting.
It's not up yet anymore? We'll try it again. Well, hopefully everybody can see this. Yes, there. Okay, so we are BayChi, and we are affiliated with the Association for Computing Machinery, and we have a bunch of people that are volunteers. It's a volunteer organization, and I'm the chair of BayChi at the moment. Happy to think about people that want to learn how to run and help design BayChi. And Edwin Lee is the vice chair. We have Steve Williams doing all the IT work. We do Nikki Philman doing in-person coordination. Publicity team is Tana Nguyen and Alexander Delory. And anyway, every first Thursday of the month, we meet for an hour and talk about what we've been up to, and also talk about what BayChi can become. So that's kind of how we roll. Today we're going to have Clara Kelley from Skydio talk. It's our monthly second Tuesday of the month meeting, and just maybe why we were being a little slow is we all had a very nice meal here. We're going to try as we can to bring food and have people get together beforehand and discuss things. But Clara is a lead interface designer at Skydio. And she, for the last 3 years, has worked on web-based and control-based ground control interfaces for products like Skydio. And she has a master's degree in computer science from Stanford, and she has a passion for UAVs when she started mentoring a class. Anyway, she's got a lot of fun over at Skydio making these things, and she's going to explore considerations for designing user interfaces for autonomous flying robots. I'm sure all of you have already read this abstract, but I'm leaving it up for a moment. And what we will do is she'll speak for about 50 minutes, and then we will, leave time afterwards for interaction and questions. And I have a funny feeling that we are going to see some flying robots tonight in this room, and we'll try to follow them around with our cameras so you can see the fun. With that, I just want to turn it over to Clara. Thank you very much for coming. Except I just want to remind people that next month we will have Terry Winograd in discussion about his career, a very amazing career where he did one of the first seminal linguistic AI theses, but also created the People, Computers, and Design a program at Stanford and ran the HCI activities there for probably 20 years single-handedly before handing it over to James Landay and company. So thank you very much everyone for coming, and Clara, take it away.
Oh, thank you so much. I'm really excited to kind of join BayChi. I had a really fun time. I'm really lucky that I get to go before Terry Winograd, because that's not somebody I want to follow. All right. Can everyone see my slides okay? I know they're not quite full screen, but I drew big. Okay. So it's my first time both as a BayHi speaker and attending BayHi, so I feel very lucky to be invited today, and I'm really excited that this community is around, and really excited for the future of it. My talk is actually pretty short. It's about 20 minutes, so we have a lot of time to explore and play with drones. I brought a bunch of batteries for folks that are here, and hopefully I'll be able to screen share the interface after my talk, so we get a chance to look around. So I'm going to talk a little bit about me, a little bit about the drones I work on, and then dive right into some of the things I've learned while working on drones for the past few years, like the importance of trust falls, explaining behavior before it happens, and how to show gaps in the capability of these systems because they're not perfect. Is my gesticulating not coming through on the screen? That would be my bad. Okay, I know you guys can't see me above my screen, so I will try and be tall. So real quick about me, Ted gave me a wonderful introduction. Yes, I came out of the Stanford HCI program with a master's in 2021 under Professor Landay, who I am very grateful to. I learned a ton from him. I have been a software engineer / UX researcher / UI designer full-time for 3-ish years. And I started at Skydio approximately in 2019, and I've been in and out of them since then. Quick disclaimer about this talk. I am not a researcher. This is not exactly science, and I can't take all the credit here. These principles are things that my team and I have learned through iterative trial and error. They're not a thoroughly tested study, and they may not be applicable to all interface work, let alone all interface work in drones, but I do think you'll find some of it interesting. I also can't take credit for the specific UI I'm going to show. A lot of the things that I'll touch on, my manager, Charles Wood, and my mentor, Mira Marquez, did a lot of the early work for. Okay, so what is Skydio? So Skydio is a drone company, started in 2014 as a project to make a robot that can capture fantastic footage of people doing interesting things with very little oversight. So the drone can basically fly itself. I won't talk a ton about the technology much here. My awesome coworkers have presented wonderful talks about how all of this works. Look up anything by Heike Martiros. You can find talks about like the core technology that we're using here. But it basically boils down to that the early team of the company discovered the thing they needed to build was a drone that can fly by itself, understanding the world around it and safely navigating around and avoiding obstacles in its path. So what is a drone? When the product that Skydio built, this is called Skydio 2, was first launched into the wild, I got a chance to interview a lot of the early users of the product to really understand what we needed to build next. And one of the things that I noticed was a lot of the early adopters were already using drones from other companies. This is an obvious thing, right? Like the people that are buying drones are people that have bought drones before. But what was interesting was what came with that, because Skydio was building their platform from the ground up, was something sort of like negative transfer. Those users of other drone companies had expectations and mental models that made the experience of using Skydio's drones unexpectedly difficult. So what do I mean about that specifically? When most people think about drones, they think about something that flies that's controlled by a controller. Their mental model is sort of like an RC car that flies. When you push it to go forward, it goes forward. It's a computer, right? It's something that is given commands and then executes those commands. And if the command is to go into a tree, it's going to go into a tree. That's just how it is. But obstacle avoidance, at least the way Skydio developed it in order to make filming really smooth, was to basically prioritize the best footage possible. So inputs do something a little bit different. Instead of forward meaning the thing goes forward, forward means there's a goal that's somewhere in front of the drone. And it will do whatever it needs to get good footage smoothly to travel to that position. And that might mean going left, right, or up or down in a way that the user doesn't expect when they press forward. So this was a big mental shift, right? What's the expectation mismatch here? Commands are now suggestions. I know that sounds a little scary, but this was actually one of my favorite insights from interviewing those early customers. Their experiences really helped me understand this concept of trust falls. This is something that I wasn't looking for, but that I found while interviewing them that I found super fascinating. So early users tended to convey feelings of fear and nervousness when they were using the drone for the first time, and some never really got over it. They continued to only use the product in the same way they had used other platforms, flying the drone as far away from obstacles as possible and only giving commands in open air. So their expectation, which was the drone that would go forward, and then they say forward, was matched, right? There's open air, so the drone doesn't have to avoid anything, so it will go forward. But those that really loved the product, those that had magical experiences, the ones that wanted to show off their videos, they'd all started by doing something that kind of put the drone to the test. They found a controlled environment, a park near them, their driveway, whatever it was, and they made a little test. The test could be something as simple as flying towards a tree and watching the drone avoid the tree. But whatever it was enough for them to start building trust with what was essentially an autonomous robot. And when that trust grew and people became really comfortable with the system and what it built mental models of how it worked, you got to see more and more examples of users doing really incredible things. This is the footage that Skydio is relatively famous for. It might seem super obvious that like you have to build trust in order to use something well, but I thought it was a really interesting way that these humans were interacting with flying robots. And especially because those that had never attempted those trust falls had wildly different experiences with the product than those that did. And this wasn't something that we guided. It wasn't like do a trust fall was in the manual. This is something that organically developed from users using the product. Part of what makes, for me, working on these drones super fun is that the team is always building new capabilities. So this is like a set of tasks that the drone is designed to accomplish. And the team calls these skills. So one example of a task is what we were just showing in the previous slide, which is tracking somebody that's moving. It's called motion track. You might have heard of the concept of a follow me drone before. That's generally this set of capabilities. But there's lots of other ones. With the idea of follow me, something a little bit more complex than go forward and avoid the tree, it took another leap of faith for users to be comfortable using the device. That not only do they just have to trust that it will avoid the obstacle, but trust that the path that it finds to capture them as they're moving is something that is going to be safe and is going to get the footage of them that they need. So how do you get users be comfortable with the drone moving on its own and charting its own path? Well, it requires explaining what's going to happen and giving the user the chance to control it. So this is the kind of key piece of early UI that the team settled on that became the foundation for a lot of other things we did. And it's called the autonomy widget. That's why my talk is sort of titled Widgets, Workflows, and More. This became a really powerful tool for communication. It's how we consistently communicate across all of these different behaviors, what the drone is going to do and when. So that first line there is the skill name. It's kind of like what application is open on your computer. This is the general category of things we're doing right now. Cable cam is a skill that basically puts the drone on a cable between 2 points. So the drone's going to stay on that line when you see the name cable cam. And then going to A, so the second line, describes movement. What is the drone going to be doing in the next second? In this case, it's going to A. So it's on the cable from point A to point B, and it's going to A. On the right, we have a stop button. This is really key, especially when you have something that moves and flies. Having a critical stop everything button with really iconic iconography to make it fun. We also show progress here, especially for tasks that may take longer, giving the user feedback of, okay, how long is this task going to take? So here's what that looks like in the UI. So this motion track skill is initiated by the user selecting a person that they want to track. And then you can see that, okay, we're doing motion track now. So it's going to be following something. And front means that it's going to be back, and front is where am I going to be following you from? So the helper text really like guides the user towards feeling comfortable with what the drone is going to be doing. It's interesting. So the controls at the bottom are a little different than like the controller controls. This is setting the goal. So the goal here is that we'll be tracking in front, so behind the user and in front of the user. Notice that it doesn't immediately start moving to do that task because the goal is smooth, incredible footage. So that's just setting the goal for the next position. Yes.
I'm sorry to ask a question,
Yeah.
but there's trust but verify. In some sense, the concern that one obviously goes to is this guy going along in front of the drone.
Yeah.
How do they know that the drone is doing well or is doing what they want to? And this, I don't see the skier having any way of seeing or understanding what the drone is doing. Well, how does that work?
So there's a couple different angles to this. The one piece is the view of the user right to the drone when it's flying is a couple different things. One, the drone itself has LED indicators on the front of it that tell you a little bit about what state it's in. Not a lot, because there's not much you can communicate with LEDs that people can really pick up quickly. So it has, I see you, or I don't see you. So that's been a really helpful signal of like, okay, I need to stop and fix something, right? But most folks actually keep their phone out, or they have their phone in their pocket and they'll check it every once in a while and see if it's getting their footage. And that's kind of an awkward interaction because you're doing an activity and then you need to check the phone. There's definitely a lot of improvement to be made there. but that's what I observed. Yeah. Yeah.
Are you open to questions?
Yes, please interrupt. Go for it. Yeah, you need a microphone. Oh, good catch.
Because the green light up.
Oh, that looks green.
The green light's on.
Okay, great. So is the stuff with me actually we interact with the stuff?
With a stop button? Yes. Yeah, I'll go back for a second. So the stop button is take this application and stop it. So you lose all state. I'll talk about that in a second, but yeah.
I was wondering about the decision.
This isn't me, but yeah, go for it.
Why the progress is show progress is actually around this stuff.
Yeah.
Semantically, to me, it's like it's going to stop maybe at some point, or it's going to stop versus separating this.
Yeah, interesting. I mean, that makes a ton of sense. Actually, in a later version of this, we moved the progress bar to the bottom of the components so that it was tracking across the UI and it was visually separated from the stop button. So that is an improvement that we made later in the design system.
All right.
But it's interesting, yeah. So if the drone is currently traveling between A and B and it's at 3/4 of the way and you press stop, it'll stop at 3/4 of the way through the progress.
Okay. Thank
That was some of the original reasoning that I remember. Cool. Did the audio come through? Hopefully, yeah. We don't know. All right, we'll keep going. Okay, so for just to recap for a second. So for controls for something like go forward, go left, go right, users were able to build a mental model of how the system worked and be able to trust it through tests, through things like trust falls. For a tracking task, something like a widget is great because the goal is really simple and the user can stop at any time and it can be described in something like 2 lines of text. But what happens when you give the drone a goal of something a little more complicated, like make a 3D model of a decommissioned power plant? This is an actual thing I did in Oregon with the marketing team as part of the release of a new skill, which was super fun and interesting, especially because the space that we're in, other lab, does a lot of really interesting work in energy. So I thought this might be a fun example to show. For a quick aside on how drones make 3D models, folks in the room, how many people know what photogrammetry is? I see some nods and some head shakes and some maybes. Okay, big picture. Photogrammetry is taking lots and lots and lots of pictures of something from a bunch of different angles, stitching the pixels of those things together into a point cloud or a mesh that makes a 3D model, or the industry name for drones is a digital twin of an object or structure that you can look at and rotate and analyze digitally. For a drone to do this on its own, a person has to help define where the thing is that they want to be capturing. And then the drone has to understand, okay, well, what do I need to do to capture what's in this box? So what's in the box and how do I travel around it so that I get all of the photos that I need? And then execute on that. So get every nook and cranny of the structure and make sure that it's all captured. This is especially useful for things like infrastructure inspection, bridges, cell towers, roads, anything that basically the cracks are important for somebody to know about so they can be prepared. And this is what I would consider a pretty complex task for the drone to try and execute on its own, right? Because we need the user's input at a bunch of different steps. So this is what the team came up with. This is something that at first glance looks very similar to the autonomy widget we were just looking at earlier, right? 2 lines of text and a button. What's different here is this is more expandable and we're going a little more granular. So that top line on the left is the step name. So what's the current task that we're working on together right now? The second line is, what are we doing in that step? What's the specific behavior that we're executing right now? And then on the right is a pause button. Interesting thing about the pause button, we ended up going with a pause button instead of a stop button because in testing, users were worried that they would lose their progress if they hit a red X. That was actually true for other skills, right? If you are tracking a person and you press stop, well, because we're no longer tracking the person, we can't pick it back up again. We don't know where they went. But with pause, you're basically stopping in the middle of an operation, but the state is maintained. So you were exploring this structure, but you still can keep exploring that structure when you resume. Okay, and what's this is the expanded view, so the much more flexible version of the UI. It's basically a wizard. There's nothing new from a UX pattern standpoint here, but it's been a really powerful tool for my team to break a complex task like make a 3D model of a decommissioned power plant and turn it into bite-sized chunks that the user can provide really precise input into. So same information, right? We've got the skill name. So this is what is the big overall task that we're talking about right now? and then progress. What's the step that we're currently on? What is the kind of current task I need you to pay attention to? Description and illustration. So this is the thing you're going to be doing and why you're doing it. And then actions. What does the user need to do? What decisions do they need to make? So here's what that looks like in the UI. So basically, the beginning of the step, you start with a full explanation of where you are and what you're doing. And then all you have to do is make a decision. And then you can see the progress of how the drone is executing on its own. I'll show that a couple times. Cool. Okay. But sometimes, right, words and illustrations aren't enough. So like an example of something like, okay, we're going to explore this structure now. This was actually super interesting to me. I've presented on this particular topic a couple times. In early user testing, pilots were absolutely terrified of this thing, right? And these are users that have done the motion tracking, done the following of the controls, and had seen it succeed at the task of doing a scan of a large area, making a 3D model, but they still weren't comfortable. And the team realized that it was because they couldn't build a mental model of what the drone was going to do next, right? With motion tracking and front, you're just like, okay, it's going to try and stay in front of me. The engineering team had built something that was optimal for the AI. It was the fastest, best coverage of the object and the fewest number of photos. It was perfect from an engineering perspective. But even after successful trust falls, right, users weren't comfortable with it. So there was two things to do to fix this. One was to make the flight path itself more explainable. So make it slightly less optimal, very slightly, by making it into a discernible set of chunks. So they took the whole area that needed to be captured and divided it into slices and smooth contours. So the drone would always be following a smooth line on a particular axis. And because that isn't enough either, because you don't really know what those contours look like, show that future path in augmented reality so that the user can see it ahead of time and understand where the drone is going to be next. So here's an example of what that looks like. This is the decommissioned power plant I was talking about. It's a hydroelectric plant near Portland, Oregon. And it's making passes, big slices like a 3D printer in this space. And those passes are converted into paths that the drone will fly. And then the user can see ahead of time, okay, the drone's going to be going this way along the path in a different direction. This is all overlaid on top of a photo that's taken during the setup step that gives the user kind of a bird's eye view of the whole plan of what's going to be executed. And so one pass at a time, we show the user, here's what the drone is going to do next. This is another example of how we use the combination of like workflow, wizard, step-by-step approach, and AR to explain to the user the planned path of the drone. This was for a product called House Scan. The goal here was to do comprehensive roof inspections. If you've ever had a roof inspector come to your house, you might have seen them climb up a ladder and go up and hook themselves in and take a bunch of photos. A lot of that is now done by drones. This was for kind of a super detailed inspection of a new roof or a roof that was going to be replaced. And the yellow cubes represent the like next path the drone is going to take, where the yellow cube is, or the, sorry, yellow facet is what the photo is that the drone is going to take next. And here's another example. This is one of my favorites. I was talking to some folks here earlier about Keyframe. This is a piece of software we designed for filmmakers to make it possible to do really complex shots that otherwise require big film equipment, dolly cams, helicopters. Basically, you set points in space and the drone interpolates a path between them. So those points are shown with the little diamonds to match the diamonds in the UI here. And then the path is shown in purple AR and the drone is traversing through it. We borrowed a lot of UX patterns from motion graphics software that we knew our users would already be familiar with. As cool as all of this is, these systems are not perfect. They make lots of mistakes. One of the things we had to figure out, especially when it comes to infrastructure inspections, where data integrity, did I get everything I need, is really, really important. Because if you miss something, you might be missing a structural crack in a bridge. So how do we make up for the shortcomings of systems that miss things? One of the big ways we do that is also with augmented reality. So here we're showing what's called the coverage mesh. Basically, the purple areas are areas that the system believes it has full coverage of, meaning we think we got it. We think it'll reconstruct correctly if you try to make a 3D model, and you're good. The yellow areas are areas that we haven't yet captured. And sometimes the system makes mistakes and it doesn't get to because there's an obstacle in the way or because it planned a path wrong, areas that are yellow. Because this happens in the air, the pilot can make a correction, take a manual photo, move the drone to a different way, to fill in the gaps while they're still in the air, saving a bunch of time. So here's the same example I showed earlier of the decommissioned power plant, but in color, so you can see it fill in the coverage as it goes along. And you'll see, even though it's finished the pass at the top there, there's parts of the ceiling that it hasn't gotten yet, right? And they might be covered by a later pass, or the user might have to go in and fill in the gaps. But a lot of the work is done for them. There was an additional pain point. This is more recent work, that users that are capturing these models day in and day out, it's impossible to identify subtle issues with the data set, things like issues with white balance, issues with like corruption of files, like anything that that would only come out in the post-processing step, unless they had already left the site and traversed back to their home base and run the processing. This is because the reconstruction portion of photogrammetry, taking those photos, making them into a 3D model, is something that is traditionally highly compute intensive, requires a supercomputer and a lot of time. So we tried to tackle this to see if we could figure out, okay, can we illuminate for the user what are the subtle issues with the data set so that they can identify them while they're still on site and either collect an additional data set or add additional manual photos. And that was kind of the concept behind this feature and this concept we called onboard modeling, where we don't make something that is to the quality that the user needs to do their work. But it is enough of a similar pipeline that it would catch those issues. So it's a simplified version of the end data that they're producing, right? Because the drone is just doing the data capture portion of what is essentially a full workflow that includes things like making a point cloud, doing measurements for engineering work, modifying the model in order to do a plan for a new building. Construction uses it for progress monitoring, seeing the difference between two dates, right? And we can't make something to that level with the compute that's on the drone, but we can make something a little bit smaller. So this is an example of what that looks like. This is the corner of my office. You can see it kind of visually looks like a 3D model. If you get quite close to it, is definitely not good enough quality, but it's good enough quality to see that there's no holes. It's good enough quality to see, okay, I got the full area that I was expecting. And this really helped users kind of nail down where were the points in their flow that they're missing the pieces that they need, and be able to fix it without having to spend the money to come back on site. So that's it for the topics here that I wanted to cover. As a recap of like 3 big things I wanted to touch on, if these are the only things you take away, these would be them. Don't underestimate the importance of building trust between your robot and your pilot. And you can build that trust by having explainable and predictable behavior and showing it to the users as far ahead of time as you can. And knowing that these systems aren't perfect, it's really valuable to give your users the best chance to improve their result through highlighting good places for intervention. Cool. I have been talking a lot. I've been talking very fast.
You have.
I am sorry.
But you have great diction. We would.
Yes. Let me get set up to. Oh, you can't hear.
We appreciate the talk, and we will. I think a lot of people are going to watch this on video later. It's just we got a lot of stuff you went through. To get it more tangible, what is a drone? What does it look like doing this? I'm very excited that you seem to have brought one.
I have.
And so I'd love you to just,
while we're still here,
give us a little tour of this drone.
Yeah.
And then before you fly it even, right?
Yeah, absolutely. So
let's get the
I'm going to move back over there so that you can see it.
Are we open to questions at the moment, or shall we wait?
Let's let her get started with that.
Let me just,
you're right.
I promise I'll be fast.
We have a lot of questions.
Okay, exciting. I don't know that I'll be able to answer them, but I will try. So this is the drone. Can you see it okay on the, okay, great. So this is the drone. It's called Skydio 2. It came out in about 2019, shortly before the pandemic. So at the end of the year. And it has 6 what are called navigation cameras on it, and 1 camera that's used for actually filming a person or whatever.
Can you point at the cameras?
Yes. So this is the camera that's used for the user. It's on a gimbal, so it's stabilized. And that allows it to take really good, really smooth footage. It's a 4K camera. On the top, we have 3 navigation cameras. These are treated as stereo pairs. So for anybody that has a computer vision background, stereo pairs are used to calculate the depth of stuff that it finds in the environment. They have the same 3 cameras on the bottom in a different orientation. And that allows it to build a model of the environment, understand the world as it's flying through. So I can turn it on. It also, so most drones come with, when people say drone, they typically mean, at least in this context, a quad rotor. So that's a robot that has 4 spinning motors, and those motors have propellers on them, and that's what allows the drone to have lift and move up, down, left, right, rotate. Yeah, fun stuff. Anything else you want me to cover on this guy, or we'll take a flight around, do some questions?
Yeah, I mean, it folds out of a little box, right?
Yes. Let me grab the case. So fun thing about the case, there's a fiducial, which is this marker here in the middle. The drone knows what this fiducial is. It knows it's its home. So if you point it at this and tell it to go home, it will go home, which is fun. We can do that later. Yeah. There's, oh yes, so you can see the case. But yeah, it's coming online now. Oh yeah, here, take it from you. Yes, fun case. Well, it's all good. And I'll get the controller out so we have it all. But yeah, I know I want to take questions. Not that I'll be able to answer them to any level of depth, but I will try. So I was talking earlier about a controller, right? Think about the mental model of an RC car. And that's what this guy is. If I can get it to open up. I'm gonna come back around because I know you guys can't see super well when I'm pointed at the camera. Controller, and the controller basically holds a phone. So we call this a bring your own device controller. And each of these sticks basically allows you to control how the drone moves, or at least give it inputs to how it should move. But yeah, let me wander around a little bit. It's also not going to bite. So if you want to, it's up to you if you want to hold it or not. Okay, go for it. Yes, it's fun. And I'll pass if anybody wants to see. It doesn't. It has an FAA registration card. I don't know if the controller is that useful to you, but the latency, like between the drone and the controller. Oh, I have a cable. Yes. Which I will plug in. Yeah, how can I help? Yeah, absolutely. Zoom. Stop share. Cool. Oh yeah, that helps. So that you can point around the room. Yes. I don't know if you want to pass it around. Yeah, it's fun. Oh, it's cool. I know this is kind of like show and tell from middle school now, but we'll get a chance to fly it a little bit. Yeah. It's a fun thing to work on. Yeah. But yeah, let me get a. It's not furry. No. I know there are folks that have done stuff to that effect, but let's see. Okay. Cool. So this one was, they're not for sale now anymore. The company pivoted towards enterprise, but this one was $1,000 when it came out in 2019. Let me make sure. I want to make sure I can get the, oops. Yeah, I wanted to just show the controller UI, at least on the big screen. Let me see. Neat. I also want to answer questions for people if I can. All right. FC ARH UYA. Join. Press to join. That's problems. Oh. Phone. Sorry. All right. Yes, start now. Great.
I assume you're going to give us a drone view at some point.
That was the goal. Yeah, if that's okay.
Yeah.
Yeah. I'll have to probably reshare to Zoom at some point. Yeah. So there actually, we have like a structure for like what the different colors mean. The blue in this case is our steady state color. It's our brand color, and it's also our steady state color. Yeah, so both the controller and the drone are solid blue when they're ready.
Right.
Yeah.
That's what I was wondering. And so
Yeah.
then does it have different, like if things are working or
Yes.
pausing?
Yeah. So we reserve red in all of our systems for there's some sort of error that requires human intervention. Typically that's like there's been a software error or one of the motors has died, something that's like really critical. Let's see. Yeah. But we also use yellow for caution. So when the drone, basically the obstacle avoidance system is always on. That's all good. It's always on except for if the user is or while landing. And so while it's landing, it turns yellow. Yes. Cool. Okay. Do you want me to share screen again, or what would you like me to do?
I'd like you to do your demo.
Demo it is. Okay.
And we'll follow you in the drone as well as we can.
Okay. I'm gonna put the case on the floor.
So that it knows where it is.
Yeah, so I'll just share. Oh, thank you, Ted. Share the UI here so folks can see. Oh, we can't both be sharing at the same time, right? Is it more important to show the UI or more important to see it moving? Whatever you want.
We can do both.
Both.
Right?
Okay.
Right. We can show that.
See if that comes through.
We got you.
Okay, cool. So you're seeing the UI that's on the controller on the big screen, and you're seeing the drone here. Hopefully, it doesn't get mad if the sun went down. All right. Cool. So, all right. So the flashing lights, because you were talking about LEDs, the flashing lights basically mean ready and armed. So it's going to move. Let me just see. This is interesting, or it can move. I'm going to use best guess here, and then we're going to start moving. Sweet. Okay. So this is that workflow UI I was talking earlier. So the user has to do 3 things that are really important. They need to tell you where's the bottom of where I should be looking, where's the top of where I should be looking, and what's the kind of inside set of things that I should be looking at. So I'm going to manually set the floor, and I'm going to fly all the way down. I'm going to set it to about our head height so that it won't flip anybody's hair. Let's see. Yeah, that should be good. And then I'm going to fly as high as I'm willing to go. Come on, buddy. There we go. Cool.
What determines how high it was willing to go?
So I'm pushing all the way straight up and it's not moving. You can't see that, but I'm not moving. That's the obstacle avoidance system kicking in. So it's saying there's definitely something above me. I can't go that way. And even though I've set a goal that's really high up, because it doesn't find a path around it, it will just stop. Okay, and now we're going to set pillars. Come on, little buddy. Okay, so just to be extra safe, let's start. And I'm going to go this way. All right, let's see this way. And you'll see it avoid the fan here in a second, if I can get it to go under. All right, we'll give it a little help. Come on, buddy. It does not like the fan, even though it's not moving.
Can you go around the fan?
Yeah, I'm gonna go around it. I'm just trying to see. Come on, buddy. I know you can see the fan. There we go. Oh, we're getting a little bit of the napkins flying around. All right, step pillar. And we're gonna come forward. Come here, buddy. Anyway, I'm not being very smart about this. I'm just pushing it in the general direction I want it to go. And then we press done. And now you can see all of us. All right. Yep. Great. Okay. Perfect. Continue.
Can you take a tour of those 3 lights at the other end of the room?
So I didn't want to fly over everybody's head, but it will take photos in that direction.
We can go around.
Let's see. But it should go around them. Okay, we're gonna do the geofence on. Continue. And so this is what I was talking about, the photo we take during setup that we use as the background for all the augmented reality. So I'm gonna set that manually. I'm gonna pull back a little bit, maybe not. All right. Set observer. And then you'll see us in that. Okay. And now we can see the mesh. So this is the drone's understanding of the environment. You can see it kind of building up on the screen. Yeah, quite fun. Sorry? Yeah, everything is on device. Yeah. Yeah, this old Note 10 doesn't have the computing power to do all the things that this guy does. So now it's going to explore. So in slices moving down, it will try and understand the environment. But because I flew that way, it really won't have to do much. That was it. That was all we needed. This is quite a small space. And now you can see it's building that coverage mesh. So we're at yellow. Yellow means we have taken no photos of anything ever. So let's see. I'm gonna turn this down a little bit. See what we get. So I'm picking the distance that the drone should try and maintain from surfaces. And let's see if we can get something. This is overlap and side lap. These are parameters for the photogrammetry. And we'll turn the speed down so you can see it move. Okay. Here we go. It's only going to take 15 photos. Are we ready? All right. So here is the path that the drone is taking in augmented reality. So it's doing that first slice at the top. Yeah, so that's the AR model of the drone. So now it's doing the second pass. And you can see this is the first person perspective of the drone. Now, I didn't set my photos particularly well. So you can see I got a lot of that yellow. So I'm going to take a couple extra photos just for funsies. Let's see. Come on. There we go, buddy. And we're going to go up. Yeah, up. Let's go. The folks around the room. Let's see if we can get a good reconstruction. So we'll take. So as I take more photos manually, you can see that it's getting a little bit of a deeper color. I do wish this had worked a little better. But yeah. Okay. And now that we're done, I will tell it to land back on its little box. So we'll come back to the little box. And I'm going to look down. So I make sure that I see the little box. All right, let's go over there a little bit. There's our little box. Come on, buddy. Oh, a little lower, little box. Okay, and now I'm going to land. And it sees the little box, and it's going to try and land on it perfectly. Yeah, it wants the head of the drone facing the gap in the circle.
Oh,
That's the demo.
fantastic. Well, obviously that was a hard time for us to ask questions, but we are now going to ask a couple questions. I'll start with a couple. And certainly, if there's more that you want to say before I start questions, please say so.
No, I'm good. Did everybody enjoy the demo? Was it not too scary? Okay, all right. I know it can be a mixed bag with the flying scary thing over your heads, but you all are good sports, so appreciate it. Yeah, absolutely.
So, of course, I don't know that all of us could appreciate everything it was doing. I hope people could hear you. But what I understand is that you that it was spending a lot of its time making sure that it wasn't running into anything, especially the fan, about a 12-foot diameter, 10-foot diameter fan in the middle of the room.
Yes,
that it
thank
was
you, Pete, for
very
turning off
worried
the
about.
fan.
Yeah. And also it was able to go up and recognize the ceiling, recognize where everybody was. And then in choosing to take those photos, you had to take, it was very aware of where everybody was and making sure that it included all of the angles as it went around. So that's my summary of what I saw it do, as well as being able to be a stable, very, very stable and responsive to you at the same time as it was really having its own, taking these very high level goals of scan the room, scan the people, avoid the obstacles. And I'm sorry, I'm just repeating
exactly
what I see as some of the really amazing things that your robot does that other people's drones do. So I want to make sure that I open it up to questions now, and we'll move on to them, and I'll probably have more later. So say your name. You should say your name.
Okay, yeah, I'm Suzanne. So I was curious about self-preservation and how it prioritizes preserving itself and the job it's supposed to do.
Yeah, so for sure. So it's funny, it's something I noticed in my language, in your language, and in Ted's language, is we kind of personify this thing, right? It's making its own kind of goals and tasks, but really it's a robotic system, and so it has specific systems that have specific goals. The drone has two systems on it. One, which is the system that kind of understands the environment and understands tasks and connects you to things, and then a safety system. And so the safety system is always online, and the safety system's job is, I don't want to flip over. So when it's executing a high level task, always in the background is this thing of like, I am not going to flip over. And it will always prioritize not flipping over and crashing into things over the task that it's accomplishing. You saw today that actually when it was done, right, there was still a lot of yellow in the room. That was because it couldn't quite get to exactly where it wanted to be to take the best possible photos of everybody in the room, while also avoiding all of us and the lights and the obstacles. This is a tough thing to explain to users.
Yeah, makes sense. So I read that as, reptilian brain and, so I see a mapping there.
Yeah, no, it's wild.
You had a question earlier? Identify yourself.
This is Alp. Why photos instead of film footage to identify the environment?
Yeah, that's a really good question. It is something that lots of companies have investigated. I think video photogrammetry as a concept is kind of a relatively new thing. The footage that is captured in video is not quite the same level of pixel detail that photos are. I'm not a photogrammetry expert. I don't know how a lot of this stuff works, but we were basically optimizing for a user who was an expert at photogrammetry, but knew nothing about drones and just wanted to make sure they got the best data set possible. And we knew that the best way to get that data set was with as high resolution photos as we could possibly get. But yeah, it certainly would be a faster experience if we could just zip around and take video rather than stopping and taking a photo each time, for sure. Yeah.
Another question? Let's
here,
get over to the.
Oh, you got it. Okay. Flying around. Go for it.
Yeah.
I'll just go stand in my little corner.
So my name is Kareem. Hey, I was a bit late, so I was watching the YouTube from outside. But
cool.
I wanted to know more about like the model that you use to detect like the safety mechanism.
Yeah.
And then also like, what are some ideal cases that you think this drone would like, where the software would excel
Great
at?
question. Can you say a little bit more what you mean by the model of the safety system?
Yeah. So like, how does it know not to crash into the roof?
Yeah. So I am not equipped to like talk in depth about how the technology works. I'll give you the like baseline, which is the drone has a set of navigation cameras. Each pair of cameras is used to build a model of the environment.
Okay.
And the drone thinks about everything in terms of goals. So if your goal is, I want to go over there to take a photo, it's going to try and plan a path through that environment so that it can take that photo.
Yeah.
That's the way it quote unquote thinks.
Yeah.
But use cases, this is the stuff that I'm really passionate about. I think one of the most effective use cases of this thing is taking photos of complex infrastructure. That's why all the examples I've shown are things like hydroelectric plants. These are industries that have like an aging workforce that's retiring out. A lot of like key industry knowledge retired during the pandemic. And so making it possible for a fewer number of people in those organizations to maintain a vast growing network of, frankly, like totally dilapidated infrastructure in the US, I think is a really useful goal. And it's quite good at finding all the nooks and crannies and taking all those photos.
Very nice.
Yeah.
So, and this
Yeah.
health assessment, like that's a crap.
I wish. That is a really cool thing. There's a lot of, so that kind of category of thing is called domain specific AI. So like an AI model that's trained to understand problems for a particular domain. So a crack looks different in a road, in a bridge, in a cell tower, all, you know, in electricity infrastructure. And so you really need like domain specific data to solve those problems. I think there's like an open problem here. And I think there's a lot of really interesting startups in the utility space that are looking to solve these problems.
Yeah, because I think the data is there,
Yes.
and then identifying the object is there.
Yeah.
And then understanding the types of cracks that could be there.
Yeah.
And how significant they could be. Even
Before
the
they get
ability
worse.
to
Yeah.
trace the crack line to another feature
Yeah.
that it has mapped. I can
And
see
get
a lot
more
of
detailed photos of a crack than of everything
Exactly.
else. Yeah. So like in a lot of ways, the ideal user experience for something like this, would you say, well, go take a look at that bridge and bring me back what all the problems are and file work orders for me, right? That's like, we can get, as we get more capability, as we understand better the problems to solve, building kind of more and more high level understanding in these systems, I think is really powerful. But today, those are tasks that are mainly done by people that really have studied for years and years in this knowledge of like what a crack looks like and what to look for. And they've seen this type of crack means water damage over here. And that knowledge hasn't been captured yet in AI. Yeah, but can be, I think.
Two questions.
Yeah.
One is all the algorithms that you guys developed or the user interface, do you think it could be also applicable for underwater?
Definitely. So the conference that I last spoke at with a version of this talk is called AUVSI, and they do both air, ground, and underwater robotics. I think specifically the piece about trust, there was actually a group from Honeywell that had a really interesting talk about autonomy and trust. Basically that like autonomy shouldn't mean, you know, the system can do whatever by itself. Autonomy should mean that the operator trusts it to do that task by itself, and it's something that's built up over time. I think the general principles there of communicating to the user what the robot's going to do before it does it, showing them where it's having trouble, and giving the user a chance to intervene, and yeah, being super clear about that. I think that's applicable to a lot of human robot interactions, not just drones.
My second question is, where do you see this, say, 5-10 years from now?
That is an excellent question. How much can I talk about? I think
We want the dream, not the plan.
Okay, all right, the dream. I think one of the really cool things about this technology as a platform, right? That like not just a drone, but a robot that can really not just understand that there's something in the way, but understand what's in its environment, is kind of a, to use a sales word, force multiplier for any kind of task that is dull, dirty, or dangerous that a robot could be doing, you know, to assist a human or in place of a human that would otherwise suffer. So like one example of something we're not actually in right now, but that I think is really impressive is nuclear fuel is stored in dry casks. And those dry casks have to be inspected by law every 12 hours. And so a person today is exposing themselves to low level of radiation to kind of traverse through the dry casks and examine all of them. And that's frustrating. That's a task that could be done by a robot, right? Could be done by a robot today. So I feel like something that I would love to see 5 to 10 years is the tasks that are, you know, really damaging to humans being partially replaced or at least assisted by telerobotics.
I have a question.
Yeah.
So, you know, you talked about, you know, replacing people's good and getting rid of employees.
Yeah, it's not. Yeah.
So that's fine. But I'm kind of more interested in performance. I expect that there are things that people couldn't possibly do as well. And that, you know, even if the same people are involved and they're all down on the floor, you know, doing what you're doing, running the robot, you're getting better performance, you're getting better data, you're doing a better job.
Yeah.
Can you talk about, you know, to the extent that you can, about some of the examples of doing a much better job with this kind of technology than anyone would ever be able to do by
I think a lot of it depends on how you define better. So one of the ways we can define better is faster, right? That you can accomplish something that a human can do today in a way that's faster. There's also like better in that you are less prone to failure. So like you catch more issues. So like, for example, a human may be, 80% good at finding a particular problem in an area, for example. An example of this that's pretty common is search and rescue, right? So like you have a large swath of area that you need to cover because a hiker has gone missing, or there's a damaged area and you need to find all of the people that could be missing. This is one of those things that I think drones, something that is specifically drones because they can go up high and get a bird's eye view of a situation, can be really, really useful at. Is that sort of the direction you're going?
Yeah, I mean, I'm saying, if you look at the mountain bike example,
yeah,
there's no way you could ever have a camera that does what that does.
You could with an expert pilot.
What?
You could with an expert pilot. So I think this is, I know. So
where's this pilot? What are they? They're on
so
an ATV or what?
The top first person view drone pilots in the world can absolutely make much better footage of things like mountain biking, NASCAR races, and they do. They're hired by directors like people like Michael Bay to film shots for scenes. If you're going to that level of detail, you can do better than a robot with a highly trained person. What the goal of this is to make accessible to more people without any training. The ability to
but
do
I'm
that
back
stuff.
to my performance
go for it.
question,
Yeah.
which is to say, I totally buy it for the being around nuclear waste. That it's going to outperform people.
Yeah.
Can it find cracks that the people haven't been able to find in places, or does it light things better than get better?
I think you're right to that. So this particular drone, probably not. This drone is 5 years old and has a 4K camera that's not awesome in low light. But camera technology continues to get better all the time. And in a lot of ways, some camera technology is better than human eyeballs, right? And so one of the things that like Skydio's new products are on, and like other companies' new products are on, is cameras that can take really, really high resolution photos of things. See a crack that's thinner than the width of a human hair, right? And that's the kind of thing that humans would miss today. It allows us to do things like predictive maintenance. So this crack isn't a problem today, but I know about it now and I can do something about it, have it not be a problem tomorrow. That's the stuff that I think is really compelling about performance. And performance, in a lot of ways in drones, comes from the cameras. Does that make sense?
Yes, it does.
It's also cost effectiveness is really important, right?
Yes, especially in industries that are, constrained in that way, for sure. Yeah, unlike talking product, but yeah. Yeah.
Hi, I'm Claudia. I have 3 questions.
Go for it.
Okay. The first one may be easier. So when it was having trouble, let's say you had an assignment and you had to get this room
Definitely.
done. So it's just something that you would keep working with the drone to eventually cover the whole space, right? Or how would that work?
Yeah. So if the goal was to do something that it wasn't currently capable of doing, which was get really close to stuff in order to take the photos that I needed, there are kind of 2 angles to that. One, reduce or increase its threshold to risk. So currently it's on like, I am worried about all the things and I need to stay, I think the bubble is 36 inches away from everything. And I can, in newer versions of the software where pilots have been like trained and comfortable to use it, reduce that. So there's, we kind of, as we move from consumer to enterprise, built out more features and more UX for the pilot having a little bit more kind of responsibility for the system. They can kind of take on some risk and say, I'm going to watch it a little more carefully, but let it go do something that's a little more risky. Does that make sense?
Yeah, that's great.
Yeah.
Okay. So for now, when you do the scanning, right?
Yeah.
Is most of the stuff that you're doing for kind of human built environment, things that are more, smooth?
Ooh, interesting.
Yeah, because that will be my 3rd question. So is that kind of what you're working with right now?
No, so the specific thing I showed you was called indoor capture. It's the bucket of skill that's like, I'm going to do something in an indoor environment. And so it's tailor-made for, there's lots of fiddly bits around. There's another set of skills, so like a bundle of autonomous tasks, which is map capture. Actually, one of the most common uses for drones today is surveying large kind of nature areas for construction sites, for understanding property lines, for all sorts of things. And that's kind of a lot more organic, but it's also a lot further away. So it's a little bit of a different problem. So we changed the skill to adapt to it.
Right, because the part of the reason I was asking is in wildfires, and one of the things that I found really, really interesting is, I got to walk a land with an Alaskan smoke jumper.
Yeah,
right?
wow.
Somebody with 19 years of experience that can
That's really cool.
go into a home and say the fire's going to wrap around here,
wow.
and that kind of wisdom, right? And that kind of amazing knowledge of reading the land. And so, how do we get to some of that capability? And so when we look at wildfire and assessing for risk, assessing for vulnerabilities and those kinds of things, I think this is incredibly exciting. Because one area is vegetation management. I saw that, that one's some of their trickier ones, vegetation health and things like that.
There are special sensors. So there are certain, so Skydio builds kind of a general platform, right? We're sort of okay at a lot of tasks, but there's a lot of startups in the space that are really good at specific tasks. The vegetation one is super interesting to me. It's not something that we focus on because Skydio pretty much stays away from agriculture related stuff, but there are actually sensors that can detect in different wavelengths of light more information about the plant than a color camera can. And it's super fascinating to look at those maps. If you've ever seen them before, it can take a picture of what looks like an open green field and show you actually this whole line of plants is unhealthy, or this set of trees is totally infested with some bug. And you could never have seen that in color pictures, but a drone that was tailor-made to understand vegetation management can be a really useful tool for a single person managing a lot of plants.
I had a question around, just thinking about laws of physics, how the real world works, and if that, getting back to that, crawling up from data to information, knowledge, and wisdom, what's needed for knowledge and wisdom, and can that be on board?
I wish. I mean, that's a really awesome question. I think we're, like you just said, I think we're at the data level right now, right? We're at the moment of kind of capturing, right? And I think to get to something like knowledge and wisdom, we have to figure out how to capture that knowledge, or how to make the folks that have that wisdom and knowledge really effective at scaling that wisdom and knowledge through tools like this. And I think that's a big next step in this that I'm not sure how we will solve. Yeah.
So I guess I want to talk about UX for a minute.
Okay. Yeah.
So here we are with trust. Now trust has this image of my eyes are closed and I'm being brought somewhere, and I just go back to this question of pulling something out of my pocket all the time.
Yeah, sure.
What have you guys explored audio feedback for keeping track of the cameras going, or have you AR glasses? Maybe even just a little indication in a pair of glasses. And what other kind of feedback did you think of, or do you think that it's all distracting?
No, I agree. It's all distracting. So I talked a little bit earlier about LEDs, right? So especially if you don't have your phone in your pocket, right? The kind of the interface of the device itself, a lot of it comes less from the LEDs itself, but people observing it over time and building a mental model. But we can absolutely do better than that. The current product that it's at, a lot of the feedback, a lot of the you're focusing on something else, but I need you to pay attention to this, and that helps build trust, is through audio. And through a notification or alerting system, which is very standard. But we focused on borrowing patterns from aviation, manned aviation, because we know that that's tried and true and tested, and we know because it's been studied by lots of other UX researchers that that's a really useful pattern for getting people to pay attention to only the thing that matters and kind of focusing down on everything else. So we have audible alerts in the new system for just a few key things. One, this aircraft is going down right now. Two, I've lost connection to the aircraft, and you need to make sure that you pay attention to when it reconnects so that you can control it again. We also have one for, hey, there is a helicopter nearby, and you need to pay attention to there being a helicopter nearby. And that's less about kind of trust in the system itself, but more just making sure that the user doesn't get into a situation where they can get into trouble. But I am sure that there is a lot more we could be doing in that space, a lot to learn from.
So another
research.
thing I kind of want you to think about is you're in a room full of UX people.
Yeah.
And maybe you have a question for us or something provocative you'd like us to consider that, might be fun for you to get us to think about.
Yeah. I mean, I think the first thing I would ask is kind of what, when you see this, when you see it flying around, what's the thing that sparks your brain of like, oh, I wish I could see or do this with it? I know that's kind of a broad question, but I'm always inspired by kind of people's different takes or different impressions. Everybody comes with a different background to how these things work. Yeah.
I'd love to see an application with CDC and the spread of disease.
Yeah, that's really
spread
cool.
of viruses.
Anyone else?
Yeah, we do some stuff with wildlife, but not CDC.
Content creation.
Whoa.
One more? Somebody got another idea? Well, I spent some time on a roof yesterday, and I did break a skylight.
Oh gosh.
And it's just people fall off
They do.
roofs all the
They
time.
do. Yeah.
So
Thanks, it's
so
all
safety.
cool.
And here we have something from Edwin, maybe from him and maybe from
Around the
Video.
other. Yeah.
Yeah, just from the chat in the Zoom.
Cool.
We have Lisa Rose suggesting she wants a drone that can paint onto exterior walls.
That would be sick. There are startups that do kind of drones that carry things that they can put on other things. Lots of companies are working on things in that space. I think one of the things that's really interesting about that is the like aerodynamics of the system changes, and you actually need like a lot more hand holding in order to move that in a safe way. So I'm really curious how they develop, how the UX for stuff like that develops over time.
And I have made a painting drone.
Cool.
But it's not commercialized it, and
No, but it doesn't need
lots
to
of
be.
problems.
Yeah.
Well, I think with that, we've covered an awful lot of territory, and it's a lot of fun watching this run around in this room that's about 15 feet tall.
Yeah.
We also have a
Really
room
good.
that's twice as tall downstairs. But I was shocked and delighted, Claire, that you were saying, "Oh, I can move around this room, no problem."
Yeah.
And it really shows just how much work's gone into making those cameras on the bottom and the cameras on top be able to really understand where it is, have a really sense of presence, which is a very, very difficult thing. Most robots have a very small amount of sense of presence, nothing like what you require to do this.
Yeah.
And I have actually seen, a few years ago, the same thing, running around in a forest, missing
impressive.
limbs,
Yeah.
missing leaves. I mean, it's an incredible piece of equipment you guys have built.
Oh, I'm really lucky.
We have a question from over on Edwin's side, it looked like.
Yeah.
Is that right?
No.
Maybe
Oh,
they deleted
okay.
it. Oh my
All
God.
good.
It was that bad a question.
You can always email me after.
We have
Yeah.
one more comment. And
Yeah, what's up?
I was thinking of a cute, name, right? Simone, with her incredible proprioception, right? In
Yeah.
gymnastics.
Yeah.
So now you have to license
There you go.
Simone Biles'
Yeah.
name.
No,
With
it's
that,
quite
I
cool.
want to thank everybody
Cool.
for coming to Bake High.
This is really fun.
And it's really great to have you. It's
Yeah,
so
thank you for
kind of you to
inviting me.
come.
This is really
And
sweet.
yeah, I really appreciate all the work and effort you put into doing
all
this,
good.
but also this talk was
Yeah.
incredible, sort of a lot of planning and a lot of effort. And
I'm
we
really
found
happy to be here.
the passion you bring and the excitement you bring to this to the work.
Sorry
we
if I
do.
talked a little fast, but I will
No.
hang out
Yeah.
for anyone else that has questions. Yeah,
Absolutely.
that's very sweet of
No,
you.
I'm
Al.
serious.
Thank you,
Like,
Al.
We go to plantations all the time, and even within Bekai over the years, yours was tough.
It
I'm
helps to
serious.
talk quickly and have a short talk and bring something fun for people to stare at.
Well, it's
But I appreciate it.
It's like being able to articulate,
Yeah,
so thank you so much for that.
thank you.
And with
That's really
that,
sweet
thank
of
you very much.
Thank you. Yeah. Thank you for all your questions. It
And we'll
was
stay
really
around
cool.
and talk to you.
Yeah,
some
I will be around, and if we have time, I brought a bunch more batteries. If folks that are here want to play and fly yourselves, yeah, we can do it. Oh my gosh, thank you. Yes, and my team is hiring.